This is one of those CKA tasks with no manifest to copy from the docs. You prepare a plain Linux box, so kubeadm can use Docker as the runtime. It is pure system administration, and you have to know the steps cold. Let's walk through it. Docker is already installed on this node, but kubeadm cannot talk to Docker directly anymore. You install cri-dockerd, the shim that lets the kubelet use Docker as a container runtime. Then enable its service. Then set the kernel parameters Kubernetes networking depends on, and load them without a reboot. Since Kubernetes 1.24, the kubelet only speaks the container runtime interface. Docker does not implement it, so cri-dockerd sits in between. The kubelet connects to the cri-docker socket, and cri-dockerd translates to Docker. On top of that, the kubelet and kubeproxy need bridged traffic to be visible to IP tables, and need IP forwarding on, which is what the sysctl settings provide. Start by confirming the gap. The cri-dockerd package is not installed, so the kubelet would have nothing to connect to, and kubeadm init would fail before it even starts. And this is a Debian box with Docker already present, so we will grab the Debian built package. Install the package the exam way with dpkg. Here the .deb is fetched from the cri-dockerd releases. In the exam, it is already staged on the box. Run dpkg-i, then confirm dpkg lists it. If dpkg reported missing dependencies, you would run apt-get install-f to fix them. But a single static package like this usually needs nothing. Now, enable and start ci-docker. The kubelet connects through the socket unit, so enable --now on ci-docker.socket, and enable the service so it survives a reboot. The socket comes up listening immediately. The service itself starts on demand the first time the kubelet connects. Next, the kernel parameters. The bridge keys only exist once the brnetfilter module is loaded, and nfcontract-max needs the nfcontract module, so load both and record them in modulesload.d so they come back after a reboot. Then, drop the 4 parameters into a dedicated file under sysctl.d, which is the persistent best practice place for them. Apply the settings without rebooting and verify. sysctl-system rereads every file under sysctl.d, so the new values take effect right now. Then read the keys back. Bridged traffic is now visible to IP tables on IPv4 and IPv6, and forwarding is on. The contract maximum is written into the same file, so it is in place for the node 2. The box is ready for kubeadm. A few things that trip people up. Use the package they tell you to and install it with dpkg-i, not apt. The kubelet talks to the socket, so enable the socket, not just the service. The bridge sysctl silently fail to apply if br_netfilter is not loaded, so mod probe it first. And always finish with sysctl-system and read the values back, because a config file that is never loaded scores 0. So, install cri-dockerd with dpkg. Enable and start the socket and service. Persist the modules and the 4 sysctl parameters, then load them with sysctl-system and verify. That is a full kubeadm node prep with no manifest in sight. Subscribe, and the full write-up is on dev.to.